Before we start this video, a large thank you to Kisipi, JW, Mohammed, a name I unfortunately cannot pronounce. Thank you for the support, my friend, and Jeremiah for their support on Patreon. I hope you guys enjoy the video. And a special thank you to Halo Burner and Humberto for their immense support of the channel this month on Patreon. It is greatly appreciated, gentlemen, and I hope you enjoy the video. Hello, everybody. So continuing down the request list, we have Breakable. So you can see here I'm in Nephilim. I roll into a crate, it shatters, I swing a sword at it, breaks the table in the store. So we're going to learn how to make these in our project now over on the tutorial. And perhaps in the future too I can cover breakables like this that explode. We can get into other special forms like heavy breakables. But for now we're just going to get into the base class and the generic version. So I have here two crates. You can see they're identical. If you want, you can make your own. All you need to do is take an object, bring it into a 3D modeling software like Blender, which is free, and basically chop it up and make one version that's whole and one version with a bunch of different broken parts like this, whatever parts you want to actually break off. Now, I will put these crates in the description for anybody who's a patron, so you can download these. These are made by Merit very quickly. Thank you, Merit. Much appreciated. And what we're going to do is basically disable the mesh renderer of the original, like this. Pretend it's just the mesh renderer, not the game object. And then we're just going to instantiate this broken prefab under it, like so. And we're going to simply optionally apply force to the rigid bodies and these little breakable pieces, or just let them fall as they are, depending on what kind of breakable you're going for. So that is going to be pretty much the gist of the system. Let's start by creating some layers now. And I'm going to make a layer for breakable and a layer for broken object. So layer, I'm just going to use 2021. We're going to say breakable, and then right below that, we are going to say broken. And I'm just going to say breakable object actually, and broken object. And then we're going to go to our physics interactions here. And I'm just going to yoink everything straight from Nephilim and copy it. So I don't have to think about this too much. So go to your physics settings, go to all these interactions, and I'm going to make it so the breakable object only interacts with, obviously, the environment, and it's going to interact with damage colliders, and it's going to interact with characters and projectiles and other breakables, obviously, but no UI, no transparent effects, etc. And for the broken object, I'm going to make it pretty much the same, except the only thing I'm going to change is that I want the broken object to not interact with characters like the breakable, but only the character's limbs. So you can run by and push it and get some, funny looking effects if you have bigger characters. Other than that though, that's pretty much it. Now I am going to assign a layer to each of these objects. So the full crate is going to be a breakable object, and the broken crate is going to be a broken object. Because as it states, this will spawn whenever the object is broken, and then it's going to fly apart. So next we can go ahead and actually start setting up our game object and then adding a script. I'm going to disable the LOD here because it's honestly not required. I'm just going to put the mesh on this main game object by pasting it from the LOD 0. And then I'm going to take the mesh filter as well. And then I'm going to delete the other LODs because this object is very, very, very simple anyway. It doesn't really require any LODs. If you're going to use this in your actual game, you want to keep it on it, go for it. But this is a pretty simple geos, so I'm just going to delete all these and just have it as one object like so. So it's a bit more simple. Now I am going to go ahead and minimize all this. I'm going to add a mesh collider first, actually. And if I go to the gizmo view, you can click convex, so it simplifies it, saves some memory. Also, this is a very simple object. I mean, it's a crate. You can add a box collider there too if you wanted to optionally. But I'm going to add an additional box collider and make it a trigger and make it a little bit bigger than the bounds of the breakable. Now, why am I doing this? Well, we're going to use this for some other ways, because you can jump on the crate when it's not broken. That's where the mesh collider comes into play. But you can also break the crate via this trigger. So we can do that via damage colliders, jumping on top of it, through it, or rolling into it. And the AI needs to be able to break this crate too when it walks up to it. And you want it a little bit outside the bounds so it doesn't get stuck on it. And it just breaks it and kind of walks through it. And it looks a bit smoother that way. But we'll get to that in a bit. For now, let's just put that on there. And lastly, we're going to make this require a rigid body and an audio source. And I think that's it before we actually start adding a script. So the rigid body is going to be kinematic. This doesn't do anything. Freeze the position and the rotation, like so. And then we're going to not mess with any of the interpolation or the collision settings. And then we're going to add an audio source. And then we're going to change the spatial blend all the way to the right here with a full value of 1. So it is a 3D space. And you can hear the sound in 3D. Next, we're going to ontick plane awake, and now we're going to add a component. We're going to add a script called a breakable object. So let's create and add this real quick. And let's open it up and let's begin dropping in our namespaces and such. So I'm going to delete the start and update functionality and put in my namespace as per tradition. I am also going to go up here and say using unity.netcode. Whoops, not Unity Engine. I'll fix that in a second. Let's put our namespace name. Man, the autofill is not on today. So unity.netcode namespace, not name of. Enter. There we go. So we're going to make this inherit from a network behavior. So it gets all of the stuff a network behavior does, like on network spawn, on network despawn, etc., etc. That means this becomes effectively a network object. So what do we start off doing with? Well, we're going to use this episode to basically lay out what we're going to use in terms of functionality on the script. And it's pretty straightforward. So we're going to make an isBroken network bool. And as you would suspect, obviously if this is triggered to broken, it's going to notify all other clients in your game, and it's going to trigger the broken effect for them. Now, there is one thing I'm going to get to, and it's client prediction. We're going to start a little bit on that with Breakable specifically, because I know it was requested. We'll go back and do it for characters' damage actions in the future too, but while we're here, we might as well put it in now since it was a requested feature. So what we're going to do for this is basically have two broken checks, one for the network and one for local. So let me explain this to you very quickly. If I have a bad connection to you, let's say I'm in Australia and you're in America, and I jump into a crate. If I have to wait to ping your game to change it to broken and have it check and break on your end and tell me, okay, yep, it's broken, and then send me back the isBroken value on the network value, and then trigger the on isBroken change, you're going to have a whole second, not quite, I'm being a little hyperbolic, but you're going to have a time where the crate doesn't break instantly, and that feels very bad. This is not responsive. It's not fun. So what we're going to do is we're going to add a local check, and we're going to break it locally, and then let the server know, hey, we already broke it. Go ahead and break it for everybody else. And it's going to feel a lot better. And since it's going to take a moment for the character to go into the crate anyway on the other end, if they're not you, then that break should basically happen around the same time that the character gets to the crate for characters that aren't you, and they're seeing your representation in game, and it's going to look like it flows together quite nicely. And on your end, even if you have bad connection, you're still going to break the crate instantly. So just all in all, it's a lot better to do it this way. So I'm going to say using system.collections. I don't think we need this video, but just in case I need to use it, I'm going to put that in my using library. And let's go ahead and continue with the variables and functionality that we need. So I'm going to make a header for this called status, as in, the broken status. And then I'm going to go down here and make another header for the mesh renderers, because again, we're not going to disable the game object when we break it. We're only going to disable its colliders and renderers. I'm saying mesh renderers because you might have a breakable object that has separate renderers and separate meshes. So because of that, or separate colliders, sorry. Because of that, we're going to store these as an array, and we're going to disable and enable all of them. And by the way, this is broken local and is broken logic. This is basically how we're going to handle damaging characters as well when we do the client-side prediction. Basically, I'm going to weigh out the damage I think I did on my end. And if the enemy's dead, I'm going to kill him on my end. And then I'm going to ping the server. And if everything works out basically perfectly, which it should, then I'm going to basically kill the enemy on my end and ping the server. Then the server kills it for everybody else. But if everything works as it should, then basically this is how client-side prediction will work. You can just kill the enemy locally on your end right away and not have to wait for the server to ping it as dead. And you can do this with all actions providing you structure the game right. If everything is always going to be very deterministic, then you can do this without having to worry about anything. You can't do it when it's left up to chaos though. But anyway, more on that later. So let's also add a header for collision and add a header for sound effects. And we're going to make the mesh colliders array. And then we're going to make a private variable for the audio source and the broken sound effects as an array if you want a bunch of random ones. And I'm going to make a comment here. When the object breaks, we're not going to disable the game object. We're only going to disable the mesh renderers and colliders, so that any network info that changes can still be passed on because the game object is still active in the scene. And I know I am just firing so much information at you. If you need to rewatch this or slow it down, go for it. I'm trying to condense a lot here into a 20-minute video. So let's make it to do here. Add an activation beacon, something you guys can try if you want, similar to how we did it for the AI. So if you get within a certain bounds, it enables the meshes and the colliders. Otherwise, it disables them. This will just save on memory, especially if you have hundreds of broken objects or breakable objects rather in a small scene space. You don't want to have them all enabled if they don't need to be. If your character is further away where they don't see them and they're not really integral to the scene, just disable their mesh renderers and their collision to save some memory. So Right below that, continuing on, let's make a header for we're going to say on break settings. And maybe you want some breakable objects to fly into space or spin around or have some force applied. And maybe with others you don't. So we're going to make a setting for that so you can tweak that yourself. Let's make a serializable field, make a bool variable, add force on break. Defaultly, this will be set to false. But if you tweak this to true, then we can just add some force when the object is broken to all of the rigid bodies that fly off of it. So we can make a float for added debris force. I'm just going to say 350. I'm just throwing a random number out there. We can change it later. And added force debris radius is 5. I'm using a radius because we're going to add an explosive force to it. And it's going to affect everything within X radius. So then let's call upon our awake start, network spawn, network despawn, on destroy. Oops, need to override that one because we're using a network behavior. Override on destroy. And then we're going to make some functions. We're going to have on trigger enter. Almost forgot that one. And then we're going to have a server RPC and a break function for actually breaking the object. So we can say private void break object, and then we can say server RPC, and then we can say private void break object server RPC. And then we can go down to right below this. Let's just say private void on is broken changed, and we're going to pass a bool for old status and bool new status. So this is going to trigger every time the network flag for is broken has changed. And then we're going to make one for private void play broken effects or break effects. And then we're going to have private void on network position changed and on network rotation changed. This is for when you spawn in the objects in the scene, because if you're using additive scenes, it's very likely that each additive scene is going to have their own breakable objects. So when you spawn them in the world, you actually have to spawn them into your main scene because only one scene can be the active scene at a time. So because of that, we got to set their positions and such. But don't worry, we'll get to that. Not important right now. And lastly, we're going to make a private void for toggle mesh renderers and pass a bool for status, whether it's true or not. So let's go ahead and make two new network variables because I forgot to make the ones for the position and the rotation. So basically, this is going to be set when it spawns. And if you ever want to update these for any reason, maybe you have a moving breakable object, then you would want to keep track of this and then change it as you need to so you can sync the position on the other clients that are connected to you. So we're just going to say network position defaultly is vector 3.0, and the network rotation is going to be a quaternion, and defaultly that's going to be set to quaternion.identity. And I am going to call this variable, of course, the network rotation. So quaternion.identity, and rename this to network rotation. Okay, very good. Let's save that. Let's go down. And let's start actually filling up some of these functions and giving them some logic. So starting off on awake, we're going to say mesh renderers is equal to get components in children. Fun fact about that, in case you didn't know, this actually gets the component on the game object you're referencing and any in the children, not just in the children. So the name is a little bit misleading in my opinion. And then we're going to do mesh colliders, and we're going to do the same thing. And if you want to fill these in or drag them in yourself, because it's a serializable field, you can. Honestly, we'll save a little bit of time, but I just like fetching it in here in case something happens to the prefab. I don't have to keep fixing it. And we're going to do the same thing with the audio source by getting it here using getComponent. But in a perfect world, if you could fill in these variables yourself in serializable fields, you would save a little bit of memory. And you got to think about it, if you're instantiating thousands of these objects, that does go a bit of a far away. So next on start, let's make some pseudocode here. We're not actually going to do this yet. Create the beacon. And if we have a world object list, we're going to basically add it to that list. So if the scenes that are tied to that are loading or unloading, then we can destroy objects when those scenes are loaded or unloaded. Okay, very good. Now, over here on network spawn and on network despawn, we can call upon our changes. So is broken.onValue changed plus equals. Then we're going to say on is broken changed. Cool. And we're going to say network position on value changed plus equals on network position changed. Why isn't this autofilling, or am I just blind? I'm probably just not seeing it. Copy and paste. Network position changed. Right here. There we go. And network rotation on value changed plus equals network rotation on value changed. So just pretty generic stuff here. You know, we're going to make it so that when this object is spawned, if at any point these variables are changed, we're going to call upon the function that is tied with them being changed, and then we're going to do some logic. So we need to make a check though. If you are not the server or the host, we're going to call it, we have to instantly do the on is broken changed. Why? Well, what if you join the game and I've already broken 6 out of the 10 barrels in the game? Obviously the status has not changed since you've got here, but it is in fact broken. So you want to just run that function when you join, and if it is broken, it's going to break the barrel as need be, or crate or box or whatever have you. Cool, so now on network despawn, we're going to just basically uncall or unsubscribe from all of these functions by saying minus equals, like so. Very good, and now we're going to say comment here, destroy beacon. This is pseudocode, we don't have a beacon yet. This is that activation beacon if you get too close or too far away from them. Now let's make a header for the instantiated broken effects. So obviously there's going to be a prefab, and there's going to be the instantiated prefab as a local variable, because you don't want to destroy your prefab, you only want to destroy the actual instantiated broken effects whenever you destroy this object. The prefab is what you're going to instantiate into this local variable. You're going to create a copy of it in the world. So whenever we destroy or despawn, these usually are the same. What we want to do here is destroy the broken object. So if instantiated object does not equal null, you can just destroy this object. Now sometimes you can, for whatever reason, I believe, despawn an object without actually destroying it. I don't know why you'd ever want to do that in any scenario, but in case you do, you could also put this call on destroy just to be safe. I don't think I'm ever going to be doing that, so I'm going to remove it for now. But just in case you want to do it, you can put it there. Now, on trigger enter, we're going to make a check for our AI character. So we're going to say AI character is equal to other.getComponent AI character manager. And what you want to do is basically say if the AI is not null, we want to break the object. Now, this is going to look like the AI is going to walk into it. It's going to blow apart. So if you want to be a little bit more stylish, you can make the AI play an attack animation here and then break it. This makes it so the AI won't get stuck in this. Optionally, you can use a nav mesh obstacle component because this is not static, and then they'll just walk around it, but I think it's cooler when they break it. So next we can make a player manager variable do the same thing and check if they are jumping, and I don't have a flag for rolling, so in the future we're going to make one, and we're also going to do that. But basically if the player is jumping or rolling, we want to do the same thing, break the object. And having this trigger box outside of the bounds makes it so you don't stop for a second, because if you didn't have that there when you hit the actual collider, your player would stop and then it would break the object and would feel stiff and not cool. But because the trigger is there just a little bit outside of it, we're going to roll and then it's going to break the object and then we're going to fly through without losing any velocity on our roll. Now lastly, check for a damage collider. Do the same thing. If the damage collider does not equal null, simply break the object. Okay, cool. Now all this talk of breaking the object, but nothing is actually in the break object function. What are we doing in here? Well, this is where we're going to basically instantiate our broken version and hide our non-broken version. So if this object is already broken on the network or is broken locally, simply return. We don't want to do anything. Otherwise, we're going to play break effects, and we're going to activate the break object server RPC. So this notifies the server, hey, that this is broken. Tell everybody else it's broken. And under the play break effects, what we're going to do is set is broken local to true, because now we know it is definitely broken on our end. And then we're going to say if the game object for some reason is not active in the hierarchy, meaning this is disabled, it shouldn't be, but if it is, just simply return. And then we're going to, right below this, actually instantiate our broken object, which I forgot to make a variable for. So we're going to say instantiated broken object is equal to instantiate, and we're going to make a variable called broken object prefab, and we're going to instantiate it at the transform of this object so it appears exactly where the other object was. And you don't need to mess with setting up a proper rotation or position if you don't want to. And since we're not actually deactivating the game object, you can parent it here and it's totally fine. Now, after we do that, what are we going to do? There might be options or reasons, by the way, why you might want to unparent this, but for this specific use case, we don't need to, so we're not going to. If we're going to add force on break, we're just going to check for that, and we're going to get rigid bodies in an array by saying it's equal to the instantiated broken object get components in children. And now we can do some magic to apply. The for loop does not want to autocomplete here. Man, it's not on today. So we're going to do some magic here and actually apply some force to all of these using explosion and a torque. So we're going to say rigid bodies I dot add explosion force. And we're just going to make the force the added debris force. We're going to pass the rigid bodies I dot transform dot position for where it's happening. And the radius, we're going to pass the explosion radius. Cool. That's all well and good. What if you want it to spin around kind of insanely and just randomly? Well, we're going to add torque direction to that by making a vector3 torque direction. And we're going to initialize it at random.onUnitSphere. So it's basically going to pick a random point in a sphere and just say, yep, that way. And then we're going to say rigid bodies I dot add torque. We're going to pass the torque direction. And now I'm going to make some variables for this because magic numbers are bad. So you could just say your debris radius and then pass that again, or you can make it variance by multiplying it by a random number. But then we're going to say force mode dot impulse. But again, magic numbers are very bad, so I'm not going to leave that there. I'm going to make a minimum and maximum torque value for this. So it's going to be the minimum amount of spin and the maximum amount of spin. And again, I'm going to haul two numbers randomly out of my head. I'm not going to think about this. You can think about it when you get into the game. You're testing it. You can tweak it in the inspector. That's what we have in serializable fields. But for now, just throw something in there. And I am going to make it. I'm going to change this first to add explosive debris force, just so the names aren't confusing. And then add it torque force, minimum and then maximum. And I'll make it like 250 and 500. That's all. So I can say 250, and I can think I spelt that wrong here. Added force torque minimum. Yeah, I'll fix that in a sec. Save, and then come down here, rename those. There we go. Minimum, maximum. So, whoa, that is 20-something minutes already. We're going to continue part 2 in the next video. And what we're going to do then is basically make it so you can roll into this object, and it will optionally fly the material and debris, depending on your explosive radius and your torque, or it will just fall to the ground. And we're also going to talk about how to set this up with a World Object Manager and spawn and despawn these objects as your scenes load. Fun fact, by the way, for those of you who don't know, you can put network objects in your scene as they are without spawning them if you meet a certain set of criteria. They're called in-scene network objects. However, since we have additive scenes, it becomes a little more complicated. But more on that in the next video. Thank you very much for watching. I hope you all have a very lovely weekend. As always, an immense thank you to my patrons. It's because of each and every one of you, the series and the content on this channel may continue. So you have my immense gratitude. Thank you to everybody who takes the time to show the series to other people, friends, colleagues, whatever. And thank you to the people who take the time to leave a like and comment on the series. It all genuinely helps so much. I will see you guys next time.